Recording.
Cool. Hello. So this presentation is called Tools of Modern Science. Mainly, I guess like the main focus is not really about the tools, but kind of the evolution and, the crossroads crossroads of where we are now in terms of like scientific advancements and the impact of other things that have happened kind of in our recent history. I'm not even clicked on it. Okay, so I couldn't find the quote, but I forget where I read it. It had to be in a book somewhere. But there was a programmer who basically said, if you want to contribute to science as a programmer, right, the best way to contribute to science is to create tools for other scientists to use, to be more effective. And we can see that kind of today as more programmers are developing simulation tools, which are awesome. So the open source movement, right? I guess I should preface this with asking, have you heard about open science? Have you heard about Science 2.0? Has anyone heard about open science or Science 2.0?
I just know no, I haven't. I've heard of Scientific Linux. That's it.
Okay, awesome. And also welcome, Alexi. Okay, so I'm not even going, like, you can read this quote. This quote's taken from the foreword of the book, The Cathedral and the Bazaar. So when we think about, I guess, like open source movement, right? We think about Linux, we think about Unix, we think about BSD, and we think about kind of the impact that they had on our software today. But Unix, Linux, BSD has had more impact on how we do science than probably any other technology, arguably. I'm willing to argue that. So what is Unix? What is BSD? Unix started in Bell Labs. That's where we get the C programming language from. This is kind of a quick overview of history. And Ken Thompson, who was one of the authors of Unix, went to Berkeley to be a professor, and they started developing BSD kernel from Unix. And then, in the 1970s, mid 70s, there was this big falling out with AT&T and BSD, I believe. They were trying to figure out how to have free software where there was licensed, like proprietary software from AT&T. The BSD side, their case was basically, hey, we have been the primary developer of this code. We've been contributing, to this project out of our goodwill. But now you're saying we can't distribute it because it has proprietary code in it. So that, was a very big issue that stopped the development of BSD or held it up. So we got the Unix kernel from that, Linus Torvald. He was very interested in the BSD project, and seeing that it was held up, he was like, we should just write a new project. And so that's basically what happened. That's how we got the Linux kernel. And so there's a series of essays that are combined in this book, The Cathedral and the Bazaar. Eric Richardson, I believe, wrote this. And really, after this book was published, you see a lot of different people moving to open source, moving to releasing things free and open for other people to contribute. And so there's two different camps inside of open source, right? There's the cathedral camp, or cathedral thinking methodology, right? Which is, there's a couple of developers who develop the code, and then we release everything open source, right? And then there's the Bazaar mindset, which is basically, we want everyone to be able to contribute to the code while it's in development before the release cycle is finished. So I don't know if you're not seeing parallels now, right? But the cathedral versus the Bazaar, this doesn't only span to software development, right? This is going to be related to what I'm going to talk about later in this talk. And so from there, we see, yeah,
like the whole Unix Linux shift, right? Like Torvalds picked it up and then started developing the Linux kernel. Is it fair that so I guess my question is, when we're using Linux today,
yeah,
are Linux and Unix, are they the same thing? Or because I feel like when I use my Mac, right,
yeah,
I can do a lot of the same things that I can do on a Linux machine. It's so close that I confuse myself, and then sometimes I'm trying to run something and it just doesn't work. So it's do you think Unix is now behind Linux?
Got you. So to answer that question, Unix was proprietary. Linux is basically a rewrite of Linux, or Linux is a rewrite of Unix from scratch, so where there's no proprietary code within Linux. So if the whole lawsuit between BSD and Unix never kind of like dragged on, and BSD was able to have their own license and to be able to distribute software for free, without like that lawsuit going on for years, we probably would not have Linux. Um, and I know Mac is based on BSD. So there's not very many differences, but there are some kind of like differences between Linux and BSD derivatives of like how you can do some things within the terminal.
Yeah, I guess the reason I ask that is because it's like the thing I'm trying to figure out is the fact that it's not proprietary allowing it to develop faster? Is it
Yeah.
a project that's becoming, more advanced because more contributions, or does the proprietary scheme win? I just feel like naturally the proprietary scheme can't really be
Yeah.
as quick as something.
Yes. Yeah. Yeah. So the whole idea is based like, or is basically, because it's open source and there's more eyes on it, that means that if you have a computer that if something's not typically supported, you can help, right? And so having the diverse support of people who have a diverse body of software, right, is probably what's driving it. You think about like Microsoft, right? They have to test it on a bunch of different computers, and half the time it still breaks, and they're just like, how do we figure out, how this works? Now they test it in virtual machines, I'm pretty sure. So it's really it's really interesting to think about, right? It's just there's not really much money to gain from releasing a code, but you can really push development, even advancement forward a lot faster.
Yeah, I kind of think about like like you could take like a Windows machine, right, and then you could put two Windows machines communicate. The classic example, like back in the 90s, you could take two Windows machines and put them on a network, and then you could put a Linux machine in between them. And because the Linux machine wasn't built to the same specification as the Windows machine, you could do things on that network and see things that other machines couldn't see. So it's like a way for you to kind of not be so restricted to like what you can do for the machine. It's more like what can the machine do for you.
Yeah, I feel that. um I feel that. So you're definitely going to enjoy these later slides. So yes, so after the whole idea of open source kind of like shocked the world, right? Because these guys are hackers. They're just kind of breaking the confines of what people thought was okay and normal. So from Netscape we get Mozilla, and now we still have Wikipedia from this movement. And so really there's always been this battle between intellectual rights and open data. There's more than ever, this digital collaboration, whether being a mailing list, online forums, IRC, and then there's the whole now because of this, people are thinking, well, should we be developing science in our own enclave and releasing it when it's ready, or should we be developing science with other people, like continually giving us feedback, right? Like, how is this Linux project so successful? So now we see like traditional science versus this whole idea of science 2.0, which is really interesting. And so this is website Science 2.0, where it's basically founded the philosophy of scientists, authors, PhDs, doctors, postdocs can basically go and share the research, basically share open information to people, right? So the idea of Science 2.0, we'll kind of talk about this a little bit more, is like open, right? Open innovation, open science, open source, open peer review, open notebooks. And it's, as I say, it's inspired by Web 2.0, which is the social web, which is we want people to see what we're doing as we're doing this. And these are like very provocative ideas, right? Because, for example, this guy, Jean-Claude Bradley, he's a doctor at Drexel University. I don't know if he's still there or not, but he's also organic chemist. And so he basically was thinking to himself, should I strive for continuing to get patents, right? Is my research having effects because I have a lot of patents? And so he came up with this idea to, every time he would do lab tests, he would basically post it online so that people would have access to his raw data, right? Oh, yes. People would have access to his raw data as soon as he conducted these experiments. And so other students wanted to contribute to what he was doing, so they would post their raw data. And he eventually had this really huge database of all of these experiments that other people who are contributing had access to that they didn't have access to by themselves, which is a really cool kind of experiment that he conducted. That the impact of that was really great, and they were able to find results that they would never have found.
Okay, so one thing about that, that's really scary that he did that at first. And
Yeah,
I mean, like, that's actually crazy. But what's weird is the reaction. I wouldn't suspect that just someone putting stuff out like that would, cause all this feedback to like start making their work better. But now I'm starting to see that like if you just put everything out there, there's no place to hide. It's like if you have a
yeah,
bad idea or like logically something is like something is illogical, and like the whole rubber ducky thing where you like tell
yeah,
Spencer and you're like, oh, I could have looked in that. They're like, did you look in that file? I'm like, no, but literally before you said that, I was thinking I should have looked there. It kind of forces that to happen.
yeah, yeah. I agree. So I guess like thinking about like the scary parts, right? Why this isn't kind of like a very accepted, like open notebooks, right? Publishing your data as soon as you gather it. Why it isn't kind of something that's super well received in academia, is because patents, right? It's really hard to patent something that everyone has access to. But also, people don't want other people stealing kind of like their advancements. They want to have credit for doing what they basically like the time that they put in and effort that they put in. And there's one more drawback. I forget what it is.
I mean, the patents are huge. The patents
Yeah,
are people just file patents just because if you even come along and you do something remotely close to what they did,
yeah,
there is a possible case to collect royalty.
yes, yes. That's true.
Hey, I don't mean to barge in, but I've been here and I haven't said anything. So I'm just trying to tell you guys I'm still here.
Oh, no worries. Thanks for coming.
No problem.
Yes. So then I guess like now like there's websites like Wikiversity, which is focus. It has two different focuses, right? Focusing on collecting course material for kids to be able to learn in an open way, which is really interesting because I feel like Wikiversity might take off in a way during COVID. I mean, I hate to say that, right? But really, they are the people set up to succeed
I don't
in
think
remote learning.
I mean, like,
Yeah,
what more could you ask for that people like? So I find that a lot of this whole virus, the onset of it is it can be chronically depressing, or you can think of it in terms of like Malcolm X was, he was in prison for a while against his will for like really nothing at all, and he used that time to read books. Like he educated himself, and then when he left, people were like, "Oh, where did you go to school?" I mean, they're like, which Ivy League did you graduate from? He's like, no, it's prison. I read all of these books because it's like, rather than taking your time and thinking like how inconsequential you are, if you incrementally like try to improve a certain skill, it, it has, I mean, even if you don't become an expert, you have to get somewhat better. So it's like, it's actually amazing that they have something where you can just educate yourself, but it's hard. I think it's really hard to educate yourself though too. I think that it's it's a very challenging thing.
it's very true. Very true. Um, and I think like even kind of like in this information age, one of the biggest, I guess, like struggles when you kind of like get access to the internet is just like where do you start, right? There's so much information everywhere. There's really a very there's no clear and concise way to become an expert at anything. You
Like
just kind of get lost.
Like you go to a YouTube video and then you're like, oh wait, this person doesn't even know how to do this thing. And I've watched this video for like an entire hour.
Yeah, sure. And so I guess like the most interesting things that we can kind of see now. I don't. Is there another slide? Oh yeah, this is the last slide. So I guess we can talk about this now, or talk about this kind of after this, after I finish. I guess going over this. So some of the interesting things that we see now is people like, I guess, professional academics who want people to have access to their science, right? They're posting pre-publishing, right, at ResearchGate. I don't know exactly how to say the first link, but that's backed by
Archive.
Yes, we'll just say that. Backed by Harvard, and another guy who's kind of motivated by open science, the open science philosophy of allowing people to have access to research without paying publishers or going through paywalls to get access to research.
Yeah, those archive papers. Some of those are like.
Yeah. Yes. Are you gonna say something? Oh, okay. So I guess I'll just skip over to that, right? You said a lot of those papers are kind of like over, a lot of people's heads, right? So there's a very interesting project. The news of this broke like last August. I'm not sure if you heard about this guy, but GNU University in New Delhi, he has like 576 terabytes plus terabytes, right, of research papers that he has in a database that he's basically text mining to allow researchers to do science, right? And so this was very controversial because people are like, oh, copyright, you're using other people's data that you didn't pay for or access. I mean, because he used Sci-Hub, right, to get access to a lot of these papers because it's like 576 terabytes. Let me actually. Can I?
76 terabytes.
It's
text.
In text, yeah, it's actually insane.
Wait, what's Sci-Hub?
No, the JNU Depot in New Delhi. He has like a database of papers.
So he called his database Sci-Hub. Okay.
No. His database is not Sci-Hub, but he used Sci-Hub to get access to research papers that were behind paywalls to put it into his own database so that he could text mine on the papers.
So he's kind of like Robin Hood, and he stole from Sci-Hub and he gave science to the people.
Well, he didn't technically steal from Sci-Hub, right? Because Sci-Hub is a bunch of hackers who basically have acquired these papers and are hosting them for free, right? Sci-Hub, I think, has gotten so many cease and desist for even hosting papers. Like, you can get access to so many papers that probably you shouldn't be able to get access to without like an academic, account or some type of journal subscription. But
okay, so Sci-Hub is like the Pirate Bay of
of research papers.
And then this person, like,
yeah,
cool, very cool stuff.
Yeah. So I mean, when you really think about it, it's like using text mining to kind of find out like what have other people found. It's a very effective way for doing research and being able to figure out like what direction you should go into. It's a very helpful tool for people who are conducting science, right? And it would make sense that this would be something that existed, but it's controversial now because of copyright. And this kind of goes back to kind of the battle that I was talking about between licensing and the Unix versus like BSD kernel. Like, we're seeing the same thing kind of happen, but there's no kind of centralized effort of fighting against copyright to say like, hey, we're trying to push science forward, but also we're sorry that you're not technically getting credit for your work. I see Evan wanted to say something.
I looked at like the average text file I have on my computer, and it was like about a kilobyte, right? So it's 35 billion. That's like 35 billion files.
Yeah. I think in the article it said like the papers go back to as early as 1847. So this is like, a premium database of human knowledge, like for the past, 150 years plus, probably 170 years. And it's a big deal, right? It's a big deal for many reasons, you know, to be able to sift through that data and get instantly like find information that you're looking for is, I think, super important.
Yeah, I mean, I guess the thing that is really helpful is the indexing, because it's like
Yeah.
you start from, and if someone were to say, "Oh, we're going to create this like entire network of people producing content and even selling things," if someone were to say that like 30 years ago, it would be like, "No, not going to happen." And then the internet came, and then you had like, I don't know. I'm kind of older, so I do remember like back in the day, you go to someone's website, be like Tom's sites, for example. And you go to this like index.html. I remember going to index.html, and you would see the hypertext links, and it would be like, click this thing, and it takes you to like Dave's blog, because that was like back in the old internet. And then finally, I forgot the dudes from Google, but they created the web crawler, which allowed them to index all of these sites by going to these links, and then eventually you could search for stuff. And it's kind of like, if that existed for, I mean, it has to happen for knowledge. It has to happen because people have to get smarter every day. Like that, just naturally, you have to deal with more information. So I feel like this is the start to probably indexing massive amounts of information and then consolidating those into things that are understandable. So it's not, because like we were just commenting about archive. It's like those papers are crazy, but the more that people digest that information and put it back out there, the easier it gets to understand.
Yeah, like
I think,
exactly. Like if you can find out that your experiment has been done before, because now searchable or indexed, and you can find it, and I feel like so much science has been done over the past 10 years, 20 years. If I'm in a lab and I'm doing an experiment, how do I know it hasn't already been done? If someone whispers to me about this tool where I can just search the experiment, that'll like be better. I feel like it's one of those things where people who figure out how to use this will just be doing a lot better science, and it might catch on that way.
yeah. So it's interesting, like, that you're thinking about indexing. I just want to like make one clarification, right? It goes further than indexing, right? So I don't know exactly how they're stripping the text out of PDFs, but they've done the work to strip the text out of PDFs to where if you search for chemical compounds, right, you can find the results of chemical compounds from previous research papers without having to like read through whole papers. So like that's the level of like,
oh damn, that's cool.
yeah.
So it's not even text. You can literally so like an image of a chemical compound, or
I don't know how they return the results, but if you're looking for like a specific result of something, and if it's in literature, then they'll give you the result.
Gotcha.
Yeah, it's insane. I think, like, I don't know. I feel like that's kind of the next step of advancing knowledge.
So
I mean, I don't. What are you gonna say?
like
Sorry.
if me or you or anyone else listening to this is doing an experiment like on Monday, and they wanted to try this out, like where did they go?
Yeah, so because it's controversial, very limited people have access to it. That's
Gotcha.
Yeah. So that's the downside.
So I'd have to go to JNU University in India.
Yeah.
Pick a flight.
Yes.
All right.
And then I guess the last thing I wanted to talk about is kind of like ethical torrenting. I think a lot of people think torrenting is bad, mainly because a lot of people torrent like movies and video games and music, and a lot of people have torrented that in the past. It's like illegal. You shouldn't do that. I think it's interesting now. I'm not sure when this website became super, not mainstream, but popular within academics and collegiate circles. But academic torrenting or academic torrents, they basically house course material, like actual full-blown classes that people can torrent and download like course material for it as well. data sets that, usually are behind, lab lock and key, because they're essential to specific labs, is progress. I know, for example, like a lab at my school has a super huge set of ants pictures that they use to train neural nets on, and they have probably like one of the biggest collection of labeled data for ants, probably the biggest in the US probably, but it's not publicly available right now. But there's a lot of publicly available data sets that like people release, and they're it's torrented, right? Because these are like not terabyte, probably gigabytes, hundreds of gigabytes, tens of gigabytes worth of data, that some people nicely seed, some people probably don't seed. But this is an open effort to kind of share data, share course material, share books, share information. So
You said ants. Is that University of North Carolina or Duke or
Charlotte.
Charlotte?
Yeah, University of North Carolina, Charlotte.
Ants. But this so I recently got a message from my brother, actually, this website where you can download like so many books, textbooks. It's just all there.
Yes. Yeah. I was gonna mention that, but I didn't know it's like that's probably going, a little bit far. That's blatantly, copyright.
I have no idea how it works. It's like a PDF. It's a little search box. And every time I go back, I'm like, is it still gonna work? Because it's too good to be true. But
yeah,
there you go.
Oh, but we gotta Zoom sometime, and I'll get you set up with Tor browser, because Tor browser is a great place where you can buy tons of illegal things.
Oh my!
It's part of
Dude, this video is gonna be taken down from YouTube.
No, I mean, like there's mad videos out there, but one of the really cool things about the dark web is that you can buy ransomware and legitimate like hacking tools and stuff, but also you can buy. Well, you don't even have to buy them. There's actually these like sites. We were just talking about the old internet. When I go to Tor browser and I go on the dark web, it makes me nostalgic for the old internet, because you go to it and it's like, it's usually like, I only go on it for like textbooks and stuff, but like, you can go in there and you can get books, whatever you want, all that stuff's there. But you go to these index pages because you can't. There's no way to index it, because everything is in its own layer, so you can't actually, see what site is connected to which site. But
Evan, set me up, man. Set me up.
a little Zoom session, get set up with Tor browser, put it in a VM.
All right.
Oh man. Yeah, but that's all I really wanted to share today. That's the conclusion of this presentation. The introduction to open science, open science 2.0, that type of idea, and kind of how it relates directly to what we see with open source. So yeah, that's all I got for today.
I guess one question is like, how do you see the future? What do you see the branches of this evolving into? Like, how is this going to evolve?
I think really I think there's still a battle going on between copyright, right, and open access to data. There has to be some middle ground of people, being able to get the credit for what they do, similarly to how, when people use Linux, they have to give credit to like we're using Linux, right? There has to be some balance between people getting credit, but then also at the same time, also balance between like not limiting who has access to data by who pays for it, right? The more people who have access to the process of things, I think is the better. I also feel like in terms of like open notebooks, people being able to see lab results, I think is a great idea. But then also like you have to like really think about, are you willing to give up a potential patent, right, to forward science or to forward like the advancement, right? I think, in a lot of ways, humans are selfish. And
right. Just to like guarantee, we need a lot of rights.
Yes. So there's going to be like a lot of wrestling between like, people wanting to like, release at last minute when they results are procured. I mean, or like the results are like pristine, and then people who want to like engage other people within communities. I think in a lot of ways it will be kind of like small communities that kind of continue to do this, continue to like grow their research with other people. But then at the same time, I feel like when these small when these small communities start dominating like specific research fields, I think other people will kind of be like, oh, actually, that's a more effective way of advancing science. It's interesting. We see it in R&D, right? We saw in R&D when like with the atomic bomb, people were sharing their results like with each other instantly, and there was probably the most productive time. I mean, probably the most productive time in technology, right? Within the last 200 years was the development of the atomic bomb. Like we got the architecture for the computer. There were so many different things developed at that time, but it was all like for, one purpose, right? I think,
Like, one person can have this idea, and this happens a lot. Whenever any of us go to bed, we have this idea, and it's half baked. But when you have other people who can carry this thing into a pipeline, it doesn't stagnate, and it doesn't. It gets carried out into fruition because the next person. I see it happen a lot. Like, when you work on like a team in like development, I'll say like, oh, it'd be cool if we had this feature. But me being lazy Evan, I'm like, I'm not gonna do that though. And then one of my friends would be like, oh, but this is how you can do it. And I'm like, well, now that you told me how to do it, now I have to do it.
I think feel that. I think it's playing out right before our eyes, right? Something crazy might happen, right? Where we all just continue to stay inside for the next couple of months, and we're forced to, share our research. How it would make sense right now to share kind of what we're, like each other, like the experiments each other, like we each are doing, right? Because not everyone has access to labs, So it's like, oh, I can look over your shoulder and say like, hey, did you see this? Oh, I didn't see this, and it's like, wow, I just accomplished something in 3 months that would have took me a year by myself.
It's funny you say that because this has been the time where I posted the most to Stack Overflow.
Yeah, but that's just my opinion. So if anyone else, has an opinion, I think.
I'd like to co-sign that opinion.
Cool.
It's totally a random, unrelated thought, anticlimactic to what what we were just saying. But so I was looking for this documentary, this O.J. Simpson documentary, like torrents, couldn't find it because I didn't want to pay. It was literally like $20 to purchase the whole set, like the whole movie. So it's like a docu-series. It's called Made in America, and I had to do it. I paid like $21.99 for this documentary movie, which was amazing. But that's I wouldn't have done that if I could find this the illegal way.
Yo, my. You see, that's what we don't want,
Yeah, it's like we're entering this period where this becomes the stuff that they're sharing now about like all these papers. I'm probably not someone who's just going to jump in and like all of a sudden start reading this. Maybe when I get like into like something specifically, I might come across a resource, but information itself is so incredibly valuable. Like even that documentary, you can put a price on it. It's nothing more than information. It's crazy because like food, commodity, furniture, commodity, clothing, commodity. But those things are so easy to get now. Like not, I guess that sounds very arrogant, but you know what I mean? They're easy to produce. They're easier to produce. And now it's like the thing that we all crave is like creative information, sources of creative information, or information that helps us improve our situation. Like those are things that we crave, like pieces of information.
Yeah, information like at the right time. You search for what you want, how to do this. It pops up. Maybe it's a free video. Maybe someone's charging for it. Information.
I think it's like at the like while we're craving information, we're also getting to a point where there's too much information for one person, right? There's too much information for even for us to process. And I think, you know, that's driving a lot of um, research even in kind of like how do we even store data? How do we even sift through and find data that's useful? Even thinking about YouTube, right? Like there is no moderation in YouTube. People like they just use algorithms, honestly. And there's just so much content posted to YouTube that, you know, honestly, one person could spend millions of lifetimes like going through it. But then, you know, it's just like you would have to continue to live because it's continually growing like with content, which is insane.
Yeah, what's interesting about that is like, you know, you point out the algorithm that they use, and the algorithm that they use is crafted by specific people. And so it's like, what about a self-organizing algorithm? One that's selected by communities. Like you go to Stack Overflow, wow, at this point, if you have a question, you go to Stack Overflow, it's probably the right answer. But that was not the case 5 years ago. I vividly remember trying to make a quadcopter and going to Stack Overflow and just getting the like flat out completely wrong answers about updating the firmware on this thing, like just completely wrong. Now it's like I could put in the most obscure stack trace from like some error, like, you know, whatever the computer tells me is wrong. I go and I look it up and it's like, oh, that's how you fix this, you know. And it came from reputation. You look at it's like 647 votes say yes. Okay, that makes sense.
Yeah, it's all about the crowd. It's like it's people hate on the algorithms, but it's such a blessing, really. Well, it reminds you of Wikipedia almost. But wait, what's a quadcopter? Is that a literal helicopter that flies in the sky?
Like back
Because
in
that's what I was thinking of when you said that. One of those like remote control things.
yeah, it's
Quadcopter.
one of those things. The thing is, it only took off for like a total of 20 minutes until it crashed and completely destroyed. And I probably spent more money on the actual making of that quadcopter than like it would have cost to just go buy it. But I wanted to understand, you know, how that worked. And yeah, it's really interesting. It was definitely one of those things that got me into like the whole. I'm gonna bring Boyd into this though, because we just talked about how like that polling thing works.
Oh boy. By the way, if you could make a presentation about the quadcopter in the future, that would be so cool.
We could
I vote for that topic.
We could do a Boyd quadcopter mashup because he directly influenced the mechanism behind the quadcopter. So he had like that whole observe, orient, decide, act cycle.
OODA loop, yeah.
And this is a guy who, I mean, in every way, it's sad how much he destroyed everyone in his life, but it was because he was so committed to doing something. And in the end, it's like you get to read what he came up with. And in this loop, it's very simple. You observe, orient, decide, act, and then readjust. We all take that for granted now, but like back when he was developing this thing that we see in business and Scrum and Agile and all these like, you know, lean development types of things, Sigma 6 is even based off of it, right? Like, so that feedback cycle it shows up so naturally in design, in picking like politicians, like voting, decision theory itself, really, you know. And so it's like you observe whatever the situation is and you orient yourself in the situation, and based on that you make a decision. And that's the thing that always like is confounding.
Is that what crashed the quadcopter? I'll shut up.
The parameters were not, so the quadcopter, the way that it works is, okay, you have these sensors, right? They're basically like an axis like this. And you can measure the angle that you tilt this way, the angle that you tilt this way, and the angle that you tilt this way. But this is the way the quadcopter should be, right? Standing up. Okay, so the wind picks it up and pushes it over here. Well, the algorithm reads in, up, I've shifted this much of this angle. I need to subtract by pushing up this thruster here. So it corrects it back, measurements back to 0. Okay, I'm good. Wind pushes it this way. Okay, well, I'm measuring an angle difference here, so now I need to correct my sensor, and I come back here, air's back to 0. I'm standing up. So in life, we have that same thing happening all the time. The self-organization, things want to get back to a steady state. So they stretch out very far to this side. Maybe they come back and they undershoot, and they overshoot, and undershoot, overshoot, undershoot, back on track. And it's like the self-organization part, it happens faster when there are more sensors. It happens faster when there's a more accurate measurement of, when there's a more accurate measurement, right? To the nth decimal. Okay, now you really are very precise. But when you're measuring to like a single digit, well, it's not super accurate. But if you're error correcting at like the billionth decimal point, it's a very accurate system.
So we want accuracy and we want speed, turning over the cycle quickly.
Yeah. Alexi, I think you're muted. You can unmute if you want. It's like a little microphone button.
I thought for a second you were talking to Amazon.
Oh, it's an Uber. So I guess we'll just say what you said. I think this a bit, it happens faster when there are more sensors. Yeah. Yeah.
Huh.
Yeah.
More sensors.
Yeah. I was about to say, when do you get to the point where, there's diminishing effects though? Yeah.
If they're really bad sensors though, and you have a million of them.
True.
Yeah, there's always a fault and all this stuff, but even that is wrapped up in the same loop. It's very dangerous to start jumping into that like mindset, because it's like, then you start to see these loops literally everywhere because it's recursive.
All I see is loop 7 everywhere.
I'm telling you.
Wake up, go to sleep.
You're gonna be like, oh man, this thing is error correcting the error that's 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 error correcting the error of this. And then you're like, it's just always, everything's always correcting errors.
Yeah, I got a call from my alma mater. They were asking for like donations like they do every year. And the guy was like, yeah, I'm from Erie, Pennsylvania. I was like, hold on. That's where John Boyd is from. The guy had no idea what I was talking about. I was so disappointed. Had no idea.
Yeah.
That's great.
Yeah, everyone here, if anyone wants to know about John Boyd, I'm happy to get you a copy of the book. I'll send it to you because it's like really life-changing.
If John Boyd was in a bad Uber, he would not hesitate to chew out the driver. Based on the biography.
He'd probably have a cigar and he'd be like tapping it out.
Exactly. That's what I was thinking. Burn it right in the other seat.
I guess that's the lesson about him, though. Is like, he did what he had to do, but
never made general.
Never made general. And some might say he completely destroyed his family.
Oh, yes, some might say.
It's like, yeah, it's a real story. It's not a fairy tale, you know.
No, yeah. I guess what we do is we learn the best parts, and then we avoid people's mistakes too. That's how I look at it.
Right.
Wish I saw the beginning of this talk, but glad I caught the end of it. Thank you.
No problem. It probably wasn't. I mean, never mind. I'm not gonna say anything negative.
Yeah, it's a awesome talk. This is something that I don't really think about that much. Maybe I need to pay more attention because I feel like I'm learning from textbooks and it's taking a really long time.
Textbooks are organized, but they don't have the latest info a lot of times.
Yeah.
The best way to learn is from other people, by doing these science talks. For example.
I think about that and I'm like, is it just me or do people just learn faster talking? Like literally this week I was with one of my friends from work and we're not supposed to be next to each other in coronavirus, but I sat down and I watched him like get a server set up and he explained like managing multiple virtual machines on a server to me in like 5 minutes, and I get it. Like I conceptually get it. And if someone was like, "Oh, you have to go do this thing," I'm like, I know the steps to do it. I don't know the specific technical details. And then you can go look that up and figure it out.
It's so true. I mean, I don't know about your specific example, but like, someone's in front of you, keep talking to you or over video. I mean, for me, these science talks, I will be like, my selfish reason is if I give a talk, then I understand what I just talked about really well. And so it's a way for me personally to improve my knowledge and also improve communication as well, which obviously that's like one of the most valuable skills, not only personal life, but working life and so on. So
shameless plug.
Yeah.
All right, y'all. Well, thank you, Trayvon, for putting this together. This was awesome, man.
No problem.